heating the water about 65 degrees, that is desired, but we don't know yet if we are going to rise to that temperature. So the project is healthy drinking water from sun. Of course, water is healthy, but we don't know if it is good or not. So that's why we are saying drinking water. So the basic idea after thinking is using a kind of box that we have around here. This red line indicates the case of the system, and we will have some valves that will allow us to. Okay, when we just take the plastic bottle, we just put it in the sun and we wait maybe 15 minutes or so to see if we can drink it. So we want to make it like in in a flow system. So we will have an automatic valve in the entrance and the outside at the output. And the container could be almost anything. It could be just a bucket or a kind of tank. And we will have the plastic water, or it could be in glass, a concentrator, which could be a friendly lens, but Professor Menon already skates, so he couldn't give us the lens. So we are going to have this system. Okay, this internal box will be the one that will have the reflector. So it will be a paint.
So
or
one quick suggestion
yes,
is, now that you have a good picture of what you want to do, you can list everything and write down how much each thing will cost.
yes,
And
that's
it'll
what.
tell you how much your bill of materials is, which is very important if you're a company.
The, that's the next point, because we increased the
Oh,
design
good, good.
and it's
Good,
fancier. So we can have just water in a glass, or we can use it portable, just changing the bottle. Of course, we are going to have the case, the automatic valves, the dispatcher valves, the Fresnel lens, polarization box, and the container. But then we came up with another idea. The valves will need something to control the input and output. So we will have the control for temperature, just to let us know that we reached the temperature, and the timer. Of course, we will incorporate include the photovoltaic cell, which
I
will
mean,
increase
well,
our cost.
yeah. So that you don't have to. I mean, I wouldn't say you would, of course, include it, because it might make it much more expensive.
Yes.
It might make it not so portable.
Yeah,
It's
exactly.
okay if you can use a battery.
Yeah, exactly. Those are the okay. We can. That's something that we are thinking about, because the price will rise really high, as well as the type of controller that we are going to use. So we are deciding if we are going to build it or we are going to buy it.
Can you use this, for instance? Let's say you're hiking
Mm-hmm.
out in the national park.
Yeah.
Can I use this and put in water from a river?
Well, that will be a more simple system. That will be only the
That
bottle.
could be a big market.
Yeah. Yes, with the reflector, the aluminum sheet on it. Yeah.
Okay, you have about a minute if you have any questions.
Hmm?
So, yeah. Huh? Well, we don't have time for it. Because I want to make sure the other students have time.
Yeah. So
Keep
we
going.
can, at the end, we are going to have something like you can carry on in your backpack, or you can have it for your house. If okay, if there's a disaster or something, you need to have something like that for more days. I mean.
Great.
Mm-hmm. Mm-hmm.
Yeah.
Yes, of course. That's why we said that we can use the plastic bottle, or we can use the glass bottle. Yeah. because they are well, we can get it from the store, we can
Yeah.
drink the juice, and then we can reuse it. So at the same time, we are reusing, recycling and reusing.
So I guess the point also is that for pasteurization, you don't need very high temperature.
Mm-hmm.
So you could in principle.
Mm-hmm.
Is that the last slide?
Yes,
Okay.
yes.
Any
Oh, well,
questions?
just the last one, which is once we have the bigger container for a house, for example, a small house in rural areas, we can have a bigger tank
Yeah.
where we can use any other material that we are thinking about it, probably steel or something like
Yeah.
that, to increase the amount of water that we want to use.
Yeah, it's very good. Very good
Yeah.
idea.
Thank
Any
you.
questions before they leave? Your option. Challenge
We know it is perfect.
them.
It's sold.
So for tomorrow, if there are no questions, I will pick. I want you to
Cost.
find out how much each thing will cost for your different ideas. Can people afford it? Who will buy it? That kind of thing. Very important. Good. Okay, who wants to become next? But that was a good example of a simple idea, which could be significant, right? Because people can use it all over the world. Kind of stuff. Not having clean water to drink is problem. Even if we can make a small impact, that can affect a lot of people.
Okay, so as you remember, our project was like a multi-purpose system. It basically doubles as a pasteurizer and a water desalinator. So this picture, as you can see, was taken like years ago. We didn't build it. It was this was a project of one of our members, but he's absent today. Uh, so basically, what he did was uh, this is his pasteurizer. So the sun came in here. This is foil, aluminum foil. So all the heat was conserved here because here he put glass. So it was kind of like a greenhouse little container with glass. And well, the user could put here the water or milk and pasteurizer, and then this system had little servo motors that would drop all the content in the pipe. Um, so yeah, to tip it, yeah. Here are servo motors, and they tilted the pot, so all the water will fell down. You can open here and add it like manually. Okay, but our project is including this into a more into a bigger system. So we didn't um, try it because, but basically is um, 2 or 3 heliostats aiming towards this spot, but this will be in the top of like a pole, okay? And that pole will have, I don't know, maybe a, no, how do you call it? Gears with gears and a crankshaft. So you will be able to lower it or put it in the hand. Yeah, I mean you lower the device like here, you feel it, and then you put it up again. Yeah. Yeah, you put some heliostats on the ground, and you can aim the radiation towards this. Now, you can also take this out from the pole and put another device that will have like a bigger roof and in a triangle shape to work it as a desalinator. So when you put it up, you will hit the bottom part of the container. You would place it the water or whatever, and then you can desalinate it. You, yeah, maybe tomorrow I will bring like maybe a design in CAD. Um,
Something simple.
yeah, just with lines. So basically, that's
So
it.
my question is, how would this be better or worse than let's say the previous idea?
Oh,
So can you compare? What?
yeah.
Why?
Well, because this is a very cheap device. This is intended to this is intended for the rural communities.
So you would say you can put one tower up in a village?
Yeah, yeah. In a rural community or
Yeah,
you know,
that's a good
and
idea.
well, it's very cheap. So maybe the government can buy all the
Yeah.
our devices and put it in several communities.
Okay. So another thing to think about, you need to list all the parts.
Yeah.
So the mirror for the heliostat, the gears,
Hmm.
the pole, whatever.
Yeah.
And I want you to list and find out how much each one costs, roughly,
Yeah.
approximately. So that's an important number too, right?
Yeah.
So if you can make it cheap enough, then people will use it a lot.
Sure.
That's good.
Other thing is that we incorporated it in this picture is not shown, but after this, here is a coil. So you heat it, and when it passes through here, you cool it. So this kills more bacteria because of the rapid change of temperature.
Okay. Yeah. Good. Any
Any
questions?
question?
No questions. Really? I have one. You can ask Spanish.
Oh yeah.
That's fine. You can ask in Spanish.
How much on a console? with a microcontroller, and I will take the energy to power it, either from a little solar cell. I mean,
Or battery.
yeah, or a battery.
It doesn't need to be perfectly. I mean, well, many of these decisions don't have to be based on technology as well, right? They're based on cost or things, whether batteries are available. That's a good question. So, yeah.
Sí, es lo que dice acá. Vamos a poner aquí un serpentín, y ese va a estar dentro de una caja con pintura blanca para que adentro se mantenga frío, y se va a bajar. Tal vez no va a estar a 0 grados, ¿no? Pero si aquí estaba a 80 y aquí está a temperatura 20 a 25, pues ya es un frío.
So the rapid change in temperature.
Yeah.
Is that what you're asking?
Yeah, the rapid change.
But even for milk, I think a few degrees. I mean, 70 degrees, right? Remember I mentioned this number?
Yeah.
So
We
it
check.
doesn't have to be, I think.
We check some data, and for pasteurization, it's about 80 degrees, and what it's called ultra pasteurization is 130 degrees.
That's good. Good question. Yes. Very good. Yeah.
Yeah.
For on the glass unit. Yeah. Excellent. Yeah. You can ask in Spanish. That's fine.
In fact, that's one of the purposes to concentrate the heat there, so it will act as a greenhouse. And if you're saying about the vaporization of the liquid itself, well, we won't heat it up further than 70 or 80 degrees.
Yeah, but what he's saying is that there will always be some evaporation, right? Because we are close and with the temperature.
Yeah.
And it will become an equilibrium with the vapor pressure outside. So your glass can get foggy. That's what you mean, right? So you might have to periodically take it out and clean it or something.
Well, actually, there's a little gap here,
Oh, I see. Okay, so you can allow some.
so I can allow it to escape from the.
We'll have to see.
Yeah.
The other question I had before we go on, we should move on, is the heliostats themselves. You have to be careful, right? Because they can get dusty, dirty, and,
Yeah.
so someone has to clean it. But I guess that's an easy thing for say an indigenous village.
Yeah, to just clean it.
Okay. Yeah. Any other questions? No.
Okay.
Who wants to go next? Feel free to get coffee and come back if you want. Or not. Okay. So the ideas are all very good. These are relatively simple ideas. And no reason why an experience at university something. Right? So that's not expensive. It's an excellent learning software. So in my class, in my class where I teach, the grade is based at the very end, the final grade is based on a business class. So it's an engineering class, but at the end of the class, students have to submit a business class. And we grade them based on the business class. So, what's that? The business class. How and I think personally, as engineers, we don't learn how to do this. This is something you hire someone else, but it's very important that you on the technology and the commercial side. It's very simple for us to make the market ourselves. Because a lot of times the technology can solve many of the cost problems. If this person looks at it, they will know how to solve the problem. And it's very important to learn that, this item. So in my class, I try to emphasize controls, the technical go to the website, they actually have videos. Those are great. Okay.
Thank you. We are working in solar water desalination, and the materials that will be used are the some glass, mirrors, and aluminum, and a wire container. The we are we will construct like a pyramid with the mirrors, well, sorry, with the glasses, and the mirrors will be used for reflecting the sun to the pyramid. And this is uh, the water, and this is the stream of water that will be collected in this collector. And because this pyramid uh, will working like a coffee maker, yeah, right? In the and
Like a greenhouse.
like a greenhouse, yes. And this collector will be in a house, for example, for isolate to the heat to the sun, for collect the pure water. Then this water will be used for agriculture or drinking. And this is, yeah.
Any questions? Yeah. What's the size? Yeah, it's a good question.
The size could be a no no much no much big in this part. In the base, you can make meters, 1 or 2 meters, but the the height could be the less that you can for concentrating more the heat.
My question is, how would you design the lenses? Like, what would you focus into the air? Would you focus on the water? Those mirrors are focusing mirrors. Actually.
Could
They
be
look like
in
you've drawn them like parabola.
yes, could be concentrating in the air for concentrating the heat here for
And then you use convection.
yes.
The air will just move.
Yes.
Yeah. Good
Wait
question.
a minute. For concentrating the steam in a, like a in a cone, como en un cono, para concentrar como un cono.
So the steam will focus into the
In
little valve.
in this tube. So focus in this tube.
So one problem I can tell, I'm going to point out, is that the tube, you have to be very careful because you have steam passing through. It's very easy to degrade, corrode. So you have to pick that carefully.
Yeah.
So that's a usual thing that fails in these tenders. Something to think about. That's right here. That.
Yes, I think in this when we are working in this, but I remember how work the coffee makers. When you have a lot of heat, they make a lot of pressure, and they sound like in
Like
this
a
food.
like a kettle,
Mhm.
kettle
Yes.
to heat, like a valve, a relief valve. Yeah, I guess if it's hard enough, then the condensation may not be a problem. You're right. There's something important to think about that. I didn't. Yeah. Yeah. Are they? Okay, I don't know. Yeah. Maybe a heliostat would work. That would be cheaper.
Yes.
If you can, similar to what the other team was talking about, heliostat, which can be quite cheap.
Yeah.
But the mirrors have the advantage that you can concentrate more than anything. Yeah.
El agua entra por este lado. No, por aquí tendría un conducto como, como un conducto, un pequeño hoyo. Este tubo como la pirámide tiene un plano, tú sí podrías hacer tipo un agujero para ingresar el tubo.
So you pour it in by hand? Or?
Yes, like we have in the pyramid, you had a plane. Then you can make a hole
I see.
for.
You can have some tube or some plumbing. Yeah, some plumbing to go in. Okay. Oh, it's a little hole in the glass. Yeah. Actually, you can put this on in the ocean. So if you have a house right next to the ocean, the whole pyramid you can put in the ocean, and you no need for any plumbing, right? Maybe.
Yes.
Like a fishing village. As well? Polarizing. See? No, wait, I lost. What is that? What is the point? What? E? Why would that help? Oh, I say, okay. Yeah, that's a good idea. Yeah, so like a filter, basically, to enhance the greenhouse effect. Yeah. I think that you can actually buy glass like that. I don't think they're very expensive. In fact, if you look at gardening stores, you can buy them. In fact, they're not glass. They're like flexible. They're plastic. They're cheap. You can build your own greenhouse. I think you go to Walmart and buy maybe Home Depot. Yeah. Okay, we need to move on. Any other questions? No. Okay, let's go to the next. You want to get your Can you speak louder?
Jóvenes, su atención, por favor. Bueno, yo les voy a hablar en español. Nosotros, el proyecto que escogimos es sobre una cocina solar. La idea de esto es poder desarrollar un sistema que pueda solucionar problemas en comunidades marginadas, por ejemplo, donde cocinan con leña o usan carbón, y eso pues todos sabemos que produce dióxido de carbono y no es muy saludable para los seres vivos, seres humanos. Entonces, como una posibilidad para esas comunidades es implementar un sistema de cocina solar. Y en nuestro proyecto nosotros proponemos crear un sistema de 2 capas de forma semisférica, como el que se muestra en esta figura, el cual va a ser bastante barato, porque lo pensamos realizar a base de material reciclable, por ejemplo periódico, como se hacen. Yes. Eh, yes. The this is the concentrator. This is the semi-spheric concentrator of heat. Yes. Yes. eh, eh. Bueno, lo pensamos hacer como se hacen las piñatas. Bueno, no sé si conozcan los que no son de acá de México, que aquí en México hacemos piñatas a base de periódico. Entonces, con esto podemos hacer 2 capas de periódico lo suficientemente grandes para que uno adentro y el otro afuera, y crear un medio como aislante entre esos dos. En esta figura mostramos que el de afuera es un como concentrador. De hecho, no todo está recubierto de aluminio, sino que de esta altura para arriba es donde está cubierto para que concentre la radiación en donde está el recipiente donde se va a cocinar. El interior, este sí está cubierto totalmente de material de aluminio. Entre estos dos, se supone va a estar sellado, a la altura de este va a estar sellado para que el que concentre más calor va a ser el de adentro, con una capa de unicel. También le vamos a poner una tapa de doble capa para que no exista fuga de calor. Parecido a este, en donde la primera capa que va a estar justo encima del contenedor de adentro, de vidrio, y habrá una separación entre ellas con otra capa que será de acrílico, con el cual se pretende que conserve el calor adentro. Y bueno, y así sería el sistema, tendría un soporte. Aquí faltó, ya no lo pudimos terminar, pero se pretende que este se pueda direccionar hacia donde esté el sol, a lo mejor unos 3 o 4 pasos, para que, bueno, se pueda direccionar un poquito. Es barato por el material que se usa y va a ser bastante eficiente y muy fácil de hacer.
Bueno, pero en este caso el unicel va a estar en la capa externa. Va a ser
Hacer la
So, so I think in the interest of time, maybe we should discuss afterwards. Because I realize we have one more team and we have about 15 minutes for the coffee break. So let's thank it's very interesting, but I want to understand it better. Maybe later you can. Yeah. So one important thing for tomorrow is try to think about how much things cost. Right? Because it's very good because we have very specific design. You can find out, okay, this costs 50 pesos, 75, whatever. And find out. That's important, very important. Yeah. Oh, what clicker? The clicker? Oh, I don't have one. I mean, I have one, but I don't know, will it work with your? Very good. Yeah. I don't have. Talk louder. Talk louder.
Good morning. Our team has chosen desalinization, and we have two proposals. One of them is for using solar for making distillation, and the other one has more it's more technological solution for electrodialysis. Then this is the range of salt that you can remove with each of one of these technologies. Distillation, you can have a limit of 2,000 ppm of salt. And if you want lesser and lesser salt in different water contents, then you need to go to different technologies. This is, for example, for which is used for water that uses in medicine for vaccines or for different things. Then the first proposal is going to be explained.
Hey, this is a very simple scheme.
That's very good. So everyone should at least do something like this. Draw an idea.
So the basic idea is to concentrate solar beams in a bucket to boil water, salt water, and pass it through a filter with a system of seals and a container for the filter, and then you have the desalinated water, and that's all.
So
That's
what
a
is
simple
passing
idea.
through the filter, the steam or the water?
Steam, steam, and then you have to.
But why do
have-
you need a filter? If it's already steam, the salt is left behind, right?
Because it's in a very small container. We are not talking about a 100 meters structure.
No, but
So-
once you evaporate the water, the salt is left behind.
Yes.
So isn't that already clean enough? Why do you need the filter? Why not just connect the steam?
I don't know. I think the steam in a very small container will evaporate and will contain the salt in the walls and in the top of the container. And I think you need the filter. I'm not sure, but I think.
I mean, but one suggestion is if you do use the filters, maybe you don't need to get the steam. Maybe you can just use expanding water or something. Although water contract. Right? Anyway. I'm just wondering if you can just heat the water up and push it through a filter. Anyway, keep going. Sorry.
But this is the basic idea. The advantage is that it's easy and cheap to build, and the disadvantage is the expensive filters that you have to change. Tomorrow we will put the prices and see what if it is viable.
Yeah.
or not.
Any?
About 20 meters for a few gallons.
The taller you make it, the more heliostats you can put in. That helps. Right? But the taller you make it, it'll be more expensive. Go ahead.
I don't know. I I will have the sizes tomorrow.
Yeah, right. Yeah, yeah. That's true. Yeah, yeah. Yeah. With the water tower. Yeah. Yeah. Yeah.
Okay, we have a second proposal that is a little more technological. It has to be with a process very well known that is called electrodialysis. Then this is an electrochemical driven process where you put a difference of potential, and you can have electrochemical reactions occurring in the electrodes. Then in order to make this reaction working, you need energy, power. Then this could be let's say, given by solar panels. Then our proposal is to substitute the typical and classic contacts made by a house power and to use photovoltaic systems. These systems can be very easily proven that it's working, because you have at the end, you inject the system with concentrate solutions, pass through the system, and the ion chloride goes in one compartment, sodium ions goes to the other compartment, and here you have concentrated hydrogen hydroxide and acid chlorhydric in the other side, and you have dilute sodium chloride as an exit of the system. Then this, when you have access to very simple test of chemistry, like a paper pH, you can test if you have an acidic solution or a basic solution at the end of the system. Then the here is to couple this to this system. And the batteries and the pencil is because, okay, in order to prove that the system is working, and we can have a panel of, and to put just the carbon of the pencil as electrode, and to see if we have enough potential to make the electrochemical reactions working. That's the way to prove. And the system needs about 3 volts to operate. It's equivalent to 2 AA 1.5 series. Yeah. This is another proposal. Yeah,
Yeah, it's good. It's interesting because you have not just one, so which is an important field.
Yeah.
Different markets, so you can charge more.
Yeah, it's for a different market, differently, because you have two products that can be sold: concentrated soda, acidic soda, hydrogen, and oxygen that are generated in the system. Besides the water.
Any questions? What is the efficiency of the process? Do you know?
Commercially known well this process. Yeah. No. Yeah, but it requires.
So I guess the other question: you have a higher potential, which is more than 3 volts. Can you improve the performance, or is there any advantage in, for instance, concentrating onto the photovoltaic?
The electrochemical reactions have a limit in the potential. Then you can, if
you
you make,
yeah,
you just lose energy.
Okay. Okay. Good. Also, think about the cost.
Yeah.
Questions? No? Okay. Yeah.
I think that the point is okay. If you have market for sodium or acid chlorhydric, you can separate the system. But if you don't have market and you don't want to deal with these products, you just mix acid and soda and you get salt. And you just do not take too much money for the residues. I mean, it's
yeah,
salt. Then
yeah, it's not toxic.
Yeah, exactly. Then you just mix this with this.
It's an important question, because you can have different strategies, right? You can have, for instance, you can lease a system and just sell the product, or you can sell the system, right? Outright. Yeah, so they're completely different business.
Yeah.
And technologically they're the same, but they might have different implications when you think about costs. So this is actually an important insight to think about. Subtle thing. I'm glad you did. So anyway, something to think about for tomorrow.
Okay.
Yes?
Yeah.
No. The two proposals, different proposals. It's like I know if you have ever seen a Italian coffee maker. These ones that are from aluminum, um, they have a bucket in the bottom with water and a filter with coffee. In it's very small,
and the water passes through the coffee when the water is boiling, but it passes not like steam, but like liquid, and you have in 5 minutes uh, a lot of coffee. Yes. And I don't know how to explain it in English. It's very difficult to me. Sí, el agua hierve en la parte de abajo y al tomar mucha presión el agua, o sea, sí, está hirviendo, pero toma presión y el contenedor es sellado, el agua sube a través de un tubo central, pasa por el café y sube a un depósito en la parte de arriba y lo hace rapidísimo, ¿verdad? Entonces la idea es lo mismo, o sea, no pasarla a fase, o sea, que no pase como vapor a la parte de arriba y luego tener que destilarlo, sino que pase como líquido de una vez. Entonces el recipiente no, o sea, ninguno de los dos recipientes es tan grande. Y solo le metes un filtro abajo, entonces puedes tener un, puedes, puedes tener una bomba acá que esté llenando una cantidad grande de agua y pasándola con la radiación solar mientras tengas buenas horas de sol. Y pues para almacenar una gran cantidad de poco tiempo. Y pues luego con el filtro, con un filtro.